The next talk is going to be about some new InfraRed exploits or security. And here's major malfunction.
Thank you. Now, it's really nice to sit down. If I look like I'm getting too comfortable here, I've been traveling since 3 o'clock this morning, so if I look like I'm dozing off, someone come and throw something over me. My name's Major Malfunction. This talk is called Old School Hacking InfraRed. And it's called Old School Hacking because it's a very old technology. InfraRed's been around forever. And actually, when I talk to people about it, I get the comment back that, why are you looking at infrared? That's just so old school, nobody even uses it anymore. But actually, in practice, of course, most people do use it. And if I go into pretty much anywhere and get a show of hands, say, okay, well, who in the room has used an infrared remote control in the last week? So, yeah, everybody. So, who in the room hasn't used an infrared remote control in the last week? Okay. Electricity will come to your village soon, I'm sure. So my name's Major Malfunction. I'm a security professional by day. My real name is Adam Laurie. I'll be presenting again on Friday with some colleagues here about Bluetooth stuff. I became known as Major Malfunction in the early days of DEF CON, when people were actually losing their jobs for going to security conferences, which wasn't very cool, and I didn't want to lose my job, so I used my gaming handle, and it kind of stuck for years. It's only recently people have started to realize that Adam Laurie and Major Malfunction are the same person. But so it's not that I'm hiding behind the name, it's just a name that stuck. I've been involved in DEF CON since DC5, and I also ran one of the first internet pirate radio stations back in the 90s. Who was that? I'll throw something heavier back at you. Okay, so why did I start looking at infrared? Basically, because as I've said, it's all around us. Everyone still uses it. It's in TV, satellite remotes. It's used for master configuration of things, not just changing channels. Quite often it's used for billing control. So if you're running a machine that uses an infrared control to turn it on and off, chances are it also uses it to set pricing and so on. So that can be interesting, particularly on vending machines. Public display signs, so those scrolling LEDs that you see in shops or on potentially even roads and in public places. Garage door openers, I think that's probably true here. Over in the States, when I say that, people look at me strangely. They've never really used infrared for garage door. They use RF. But I think over here in Europe, it's more common. And the thing that actually got me interested in the first place was car locking systems. I had an early BMW which had an infrared control, and I found that I could clone the close and open commands from my Palm Pilot and just open and close my car with my palm, which was pretty cool. That's a good trick, you're walking along playing with your palm and the door opens. And then I upgraded it and it stopped working. And what I found with the new car was I could do it once, and then the next time I used the key, that code didn't work anymore. So I started to get curious about, well, what's the actual code that's being sent? They must be using some kind of rolling code or something, and I wanted to see what the code was. So that's why I started looking at it. I called it MMIrDA. The subtext for this talk is Major Malfunctions Infrared Discovery Application. So I started actually writing a program to analyze the infrared codes. And it's the classic pun, so IRDA plus MM gives you MMIrDA. And that's because I was using the built-in IRDA port on my laptop to do the reading of the codes. And I got quite far down the road. I could actually read the codes, and I started to get to a point where I was trying to send them back. And I wrote this tool under BSD. And then I discovered Lurk, which only runs under Linux. And so I overcame my Linux bigotry and moved from FreeBSD to Linux, and now I've pretty much stuck on Linux because of these tools. So yeah, all you Linux people out there, it's not so bad after all. Still use BSD for servers, of course. So, yeah, why bother even playing with it? Well, I think InfraRed, it's been around forever, and it's unlikely to be replaced. It's very fit for use. It does its job very well. It's cheap. It's simple. The old rule, you know, if it ain't broke, don't fix it, applies. I don't think new technologies that are coming along can compete. Things that, you know, people say, well, it'll get replaced with Bluetooth or whatever. So, you know, Bluetooth problems aside, which we'll talk about on Friday, it's not an appropriate technology for something like a TV. You know, if you're sitting in a room and you don't want the TV next door to be able to change accidentally because of something you do, InfraRed works very well. It's not going to get out of the room. It's not going to affect things around you, or at least that's the theory. But yeah, watch this space. So I don't think it will change. And because it's there, I think, you know, it's one of those things. If you're into security and you have a curious mind, which obviously you all do, or you wouldn't be here, it's something to explore. And anything that's in any way security related is worth exploring. If there's anything that's controlled by something, then there's probably a security issue there. Somebody had to think about, how do I manage the security behind this system? And if you start looking at it, you find tiny little holes in it, and you pick away at those holes get bigger and bigger and bigger until you find actually they're gaping great wounds. And that was the case with this. You know, when I started playing with InfraRed, I found some tiny little anomalies, which have now, as you'll see, it fills an hour of discussion about all the all the interesting things you can do with it. And it's fun, all work and no play and all that. So, okay, so it turns out that InfraRed is the absolute ultimate in security by obscurity. Because it's sending invisible rays that nobody can see, they've used really simple codes. And quite often, the security models behind it, when they implemented it, because nobody can see what's going on, they haven't even bothered to implement a sensible security structure. So they often have what I call an inverted security model, which is where the end user is controlling what the device can do. This is common in satellite systems, you know, in decryption systems. They're broadcasting everything, and it's the receiving end that decides what you can and what you can't see. And that tends to be true with infrared controlled stuff, that it's the receiving equipment that you now have control of that's actually deciding what you can see on the device. And hotel pay-per-view is a good example. We'll look at that one in detail. When we get onto the picture slides, can we turn these lights down a bit, because some of them don't look so good if you've got bright light on them. Okay, so to start with, I mentioned I was able to replay my car control. And I found that's also true of garage doors, toys like the RoboSapien, TV standards. They're so standard that, you know, people sell remotes that you can use to control multiple TVs and so on. And that can be useful if you're sitting in a sports bar and you want to piss everyone off around you, change the channel to the Disney channel or something. Yeah. And if you ever see a special remote, you'll know it because it'll look just like the one in your room, only it'll be red or something. So you want to clone that if you ever see one of those. So the tools you can use for cloning and replay attacks, one of the very first tools that came out, I think in the 80s, was like a Casio watch, which I thought had gone out of production, but we found some in Bangkok recently and bought a couple, and I've programmed them to do some of the hotel tricks. So that's quite cool. You walk around with your James Bond watch and do stuff to the TV. Apple Newton, guy called Lars Imisch, who might even be here, who's from the local scene, wrote some tools, again in the early 90s, I think, to do some infrared control stuff. And the standard for Palm, I mentioned the Palm a couple of times, there's a program on there called Omni Remote, and they've now got a standard which you can download from Pacific Neotech, and there are various tools for publishing your code libraries, and there's huge libraries online as well. Philips Pronto, again, is another standard, and there's now tools that will swap between the Pacific stuff and the Philips stuff. The Philips ones are really cool because they're typically just a flat screen device, and you program the buttons and the actual code, so you can make it look and feel however you want. They're quite pricey though. And importantly, they're human readable form. So if you're going to play with these codes, you need to be able to see what the codes are. Okay, so here's the first example of a replay attack. This one I did at DEF CON a couple of years ago. I think it was DEF CON 12. There was a guy walking around. He'd bought one of these toys, and he'd played with it, and he'd obviously got bored with it, and he didn't want to carry it all the way home. So he was walking it up and down the lines, the queues of people waiting to go into talks. If anyone here who's been to DEF CON will know that you do a lot of queuing. Hopefully that'll all change this year. We have a much bigger venue. So he was walking up and down with this sticker on it saying, "Buy me." So I sat in line with it and started recording the codes. Can you see that all right? Do we need to get the lights down a bit? Is anyone there on the lights? Please. No. Hopefully someone will do something about it. So I sat there, recorded the codes, and then he would walk it up the line, and I would play the code that turned it around and walk it back again. So he'd walk it up the line, and I'd turn it around and walk it back again. So we played like that for a few minutes, and I don't think he managed to sell it, but I owned it. So. Similarly, there's a guy at work who has an infrared car locking system. So I put my receiver in this green car here, and when he left the night before, I recorded the lock code. So next day, when he goes to leave, he walks out to his car, and he opens his car, and I lock his car. And he opens his car, and I lock his car. And he opens his car, and I lock his car. And we played like that for a few minutes. So he got completely fed up and went back in the office to phone for a garage. I said, okay, yeah, I'll let you in now. But I couldn't actually steal the car because he also had an RF disabling system, but again, more about those later. Okay, so that's a simple replay attack. So if you can see the code, you can record it, you can play it back. But what if you can't see the actual code that you want? You can see a similar code, but not the one that controls that actual device. So I was curious if I could actually brute force these codes. If I can analyze what the code looks like, maybe I can send every possible code and actually brute force some kind of device. So again, I looked at garage door openers, because they're handy, TVs, and cars. And to do that, the brute force tools I used was Lurk. Now, Lurk is the Linux infrared control project. It's freely downloadable, open source, works under Linux only because it has some kernel hooks in it. Most importantly, I think it has a visualization tool. I find that really useful when you're looking at these things. Instead of just staring at meaningless hex numbers, you can actually see patterns of the data that you're looking at and see where the vulnerabilities may lie. Thank you. And that's, as you'll see later on, that becomes quite important. There's also a device called the InfraRed, which is very similar. It will also automatically learn codes, and it will produce human-readable files, which you can then mangle. That you can buy online from irtrans.de. Also solves some timing issues. When you're using the infrared port on a laptop, what you're actually doing is messing around with standard serial protocols and trying to emulate what an infrared is doing. With InfraRed, you're actually sending the codes in native mode, so they work on more complex systems. And that's what it looks like. It's just a little USB dongle. Okay, so here's the first example of a brute force attack. So this is my infrared garage door opener. And as you can see, it has inside a dip switch, which sets 8 possible switches to set the address of the garage door. So your garage door doesn't open next door's. Your opener doesn't open next door's garage, unless you sit there and try all 256 combinations, of course. So this is the visualization tool that you get with Lurk. It's called Xmode 2, and what it does is it just draws you a picture of the modulation of the carrier frequency that's used in infrared. So with my garage controller, I set a bunch of different switch settings and then blasted it at X mode 2, and these are the patterns that came out. So here, when all the switches were on, I get a bunch of long pulses. When they're all off, I get a bunch of short pulses. When number 8 is on, I get one long pulse here, and so on. So it was clear that what was happening is we've got an 8-bit data pattern here, a start bit, and some stop bits. Very simple. So you learn those codes with Lurk, and what you get is a text file which has some timing information in it. This is to do with the timings of the ones and the zeros, which you don't particularly care about. And these are the actual codes that I learned. And as we can see, 0 is 0, all on is FF. So it's basically just a hex representation of the 8-bit code. So I write a little Perl script that spits out every possible code, paste that into the config file, write another little script that spits out each code, and it then took 54 seconds to send all possible codes. So here I am in my underground garage, fire up my laptop, start it going, and hey presto, the door opens. Now this wasn't really a big surprise because I knew I had the right code. You know, I had learned it already. I mean, I did go through the exercise and brute force it, and the door popped open, but strangely it popped open, the real code was like E5 or something, so it should have popped open towards the end of the sequence. What actually happened is it popped open in the first 10 seconds. So at first I thought, okay, there's like a backdoor code in here. The manufacturer has got a code that always works, so he has a master remote, and that's going to be really useful. Actually, no, it turned out that the guys who run this garage, this is a shared underground garage, they had gone to get some more remotes, and the company that supplied them had gone out of business. So they'd found another company who came along and went, ooh, yeah, difficult job this one, Gov, we'll have to put in a whole parallel system. So if you look here, they've actually got 2 receivers. And what they're doing is they've got 2 completely compatible systems and bolted them together so they both control the same door, when all they had to do was get the dip switches right on the new receivers, or the new senders. So if they'd had my tools, of course, they would have known this, but they didn't. And the other thing to note in this picture, all you security-minded people, sorry, come on one, will have spotted the camera there. So obviously, if I'm mucking about in a garage with a laptop and doors are opening and closing and I'm messing around and there's a camera watching me, what's going to happen? I'm going to get arrested, right? No, not a thing. Nobody mentioned it. So, you know, if you're going to put cameras in your places, watch the pictures. Yeah, see what people are doing. It's probably not good. Okay, so that was a really simple case, garage door opener. So I then wondered, well, can I apply that to hotel TV systems? In hotel TVs, they tend to apply this inverted security model. So the TV is controlling what channels I can watch. So maybe I could brute force the codes, tell the TV to open up some more channels. And you know, the suspicion was that the hotel was broadcasting all the content, the TV's filtering the content, that I didn't need any authentication to get into the system and change the commands and so on. And it wouldn't be encrypted. And the reason it wouldn't be encrypted is because it's a closed system. They don't need to encrypt it. They control the whole thing from end to end. So why would they need to encrypt it? And the way we can tell if they really are broadcasting the system is we could take our own TV in and plug it in and tune all the channels in and have a look. But that tends to raise a bit of suspicion when you're standing at the check-in desk with a Philips under your arm. So I carry one of these instead, which is a little USB TV tuner. Sure enough, if I plug it in, some of you may recognize this TV if you're staying nearby. So here's the TV showing the hotel system main menu, and here's my laptop showing another channel. And I scan through the various channels, and there's another one, and another one. And this one puzzled me for a while because it appears to be an advert for the company, that are providing the back-end system. But nobody's ever going to see it. If you went through all the possible channels on this TV, you would never see that screen. And I couldn't understand why they would bother transmitting an advert. It actually became clear later this wasn't an advert, this is a screensaver. And on the screensaver is a very useful piece of information. It's the URL of the company that installed the system. So you go to that website and have a look, and there are data sheets for the system, tells you all the capabilities of what this thing can do, the hotels they've installed it in, the new features they're working on, which hotels have those features. So you can look at it and say, oh, interesting, credit card system, I might go and stay at that hotel. Or one of them, they're deploying webcams. Why would you want a webcam in your hotel room? I think I can guess. Could be a whole subject of another talk. And of course, they're broadcasting premium content. So this is a movie that I should be paying for, and here it is being broadcast on the system. Does anyone tell me what film that is? School of Rock, yeah. So, and if you're feeling really cheeky, you can feed that back through the SCART and watch it on the TV as it was originally intended. So. Okay, so very interesting. We've now proved that they're broadcasting stuff, but we haven't actually done anything to the TV. We haven't taken control of it. So I started looking at the codes, the InfraRed codes that the TV remotes were sending. And it turns out they're much more complex, a lot more bits involved. And the main reason for that is there's a lot of manufacturers using identical technology, so they don't want to be switching each other's devices randomly. So when you've got a Sony TV and a JVC video, you don't want power off for one of them to switch the other one off. So they have a manufacturer ID code on the front. They tend to use grouping, so they have another few bits which says this is a standard code, like a channel select or a up, down, left, right command. They have extra groups that only appear on hotel remotes, so like alarms and checkout buttons, and some interesting hidden ones, which is what we're looking for, of course. So this is the visualization. And as you can see, it's a much longer code than the garage door one. But this is where I think the visualization stuff comes in really useful, because at a glance you can see that most of that, if you looked at it as a hex number, it would be a bunch of really horrible hex numbers. But with the visualization, you can see that most of it's the same. So we only really care about this end bit. So the front is not changing, the last few bits are changing. Okay, but even so, we've got a 14-bit code which gives us 16,000 possible codes. Now, unlike the garage door, where you're just waiting for something to happen, you're waiting for the garage door to open, with TV codes, you're waiting for something to happen which may only produce a momentary result. So if you're not observing it when it happens, it'll be gone. The next code may cancel it out, it may just time out. So you do actually have to observe every single code that you send and see what happens. And I worked out it takes about 2 seconds per code, so that's 9 hours to test the whole lot. And I mean, obviously I am a sad geek and I don't get out enough, but even I draw the line at watching a TV for 9 hours for something that's going to happen, maybe. So I had to come up with a way of reducing the search space. So basically I recorded all the codes that were available to me in the hotel room. So I send all the commands 0 to 9, and I look at the bit pattern. So in this case, this is the code that's being recorded in the human readable lurk config file. So we've used the first 2 bits, and then gradually as we go through the sequence, we start using these bits. So go through the whole lot, power, mute, volume, so on. And I've sorted these so that we're building up a picture of what bits are changing. Finally, we get to the end, and I've seen all these bits change, and I've seen these 2 bits change. These 4, I've never seen what they do. So my assumption is the first 2 bits are definitely used, 4 bits are unknown, and the main code is in the last 8 bits. So now I want to try and knock out some of those. I mean, clearly the last 8 bits I'm going to be having to test each of those because that's the main code, but maybe I can get rid of some of these. So I take my original command, in this case power, and for each bit of the ones I want to test, I toggle it. So if it was a 1, I set it to a 0. If it was a 0, I set it to a 1. And I retransmit that command. If it succeeds, then I can be pretty sure that that bit's ignored. I don't care about it. I don't need to test it. So when I've done that for all the possible bits, I got to the end, and I had 10 bits I actually care about, which gives me 1,000 codes, which is 2,000 seconds, about half an hour. I can live with that. That's fine. So I wrote a new config, which has the 8 bits on the end, plus 4 different lead-ins. I mean, I could have done this with 14-bit Perl code. If you know how to do that, please don't tell me. I really don't want to know. It's probably very evil. And then you just send all of those codes. And sure enough, I found a bunch of interesting things, which I've labeled. Some of them are engineering codes. Some of them are what I call housekeeping codes. And this is the one you really want, the God code. So the kind of codes that you find are housekeeping codes. So these are things that are done on a routine basis by the cleaning staff, for example, or the people who are replenishing the minibar. So they carry around in their apron, they'll have a remote which has these extra commands on it. The engineers who set up the rooms or debug or troubleshoot problems will have a different remote that has a bunch of other stuff that they can do. So these are the debugging codes and so on. And there are some services you can switch on or off with a button on the remote. So now I've got my new capabilities. What can I do? Well, I can change messages on the TV. I can assign the TV so it thinks it's in another room. I can assign channels that are now free, that didn't used to be. And I can find channels that actually don't even exist, like the one with the screensaver on it. So, first thing every good hacker has to do, obviously, is tag the thing that they've owned. So, there we are. This is what will come on in a particular room in a particular hotel in Las Vegas. And if you can tell me which room it is, I'll give you a system. I think, as far as I know, it still does that. So. Same thing in Amsterdam. Or you can actually change the whole message that comes up when you power the TV on. So it's not just the channel identity, it's the whole thing. And you can even lock the thing and really own it. So. I'll try and give a shout out to whatever conference I'm speaking at. So. More of the same. I'm not going to tell you where I was. Okay, so one of the other things you can do that's pretty cool is change the channel filtering. Now with most, particularly in America, most of the content goes out with electronic kind of tags on it saying what kind of program it is. So potentially you can filter what the TV will allow and what it won't allow. So here we have a system where they've rated the movies from G through to not rated and X and so on. But as you can see, this has been left dangerously wide open. I mean, anything could come into my room. It's been totally left open, and I felt I had to take matters into my own hands. So now only the good stuff comes into my room. So. None of that sport or news crap. So. Okay, so what else could you do? You can view the back-end systems. So here we have a test channel, not very interesting. Actually, it turns out to be slightly more interesting than not very. These numbers are normally a sequence of numbers, which is some kind of code. And it seems that if they accidentally get set to 0, then the minibar stops billing or something like that. I don't know why that would happen. You get some debugging info, which is vaguely interesting. More of the same. Another good film. But this is interesting information, but it's not actually telling us anything we shouldn't know. However, you start to see stuff that potentially we shouldn't be seeing. So here we can see we're running a DOS system, and we've even got an IP address. So we're starting to see leaked information that we really shouldn't be seeing, that could be used in another, as another attack vector. And then sometimes you see stuff you just don't want to see. So. Okay. It's kind of weird and sort of kind of harmless, except it turned out that that arrow was connected to the up, down, left, right buttons on my remote now. So I can move it around. And I found a page with a link on it. So I moved the arrow and I clicked on the link. Oh, that page can't be found either. But Microsoft helpfully suggests, well, if you can't find that page, why don't you go to the home page of the server that tried to serve it to you? Okay. I always do what I'm told, so. Ooh. Oh dear. So I'm now running their main IIS server in the hotel. How did that happen? Sadly for me, unfortunately for them, the batteries were flat in this thing. And it was 8 in the morning and I had a meeting to get to and I had to leave that particular hotel, but I will be back. Now it starts to get really scary. So I have a desktop and again I can move the cursor around. And I can launch applications. Bit of tidying up while I'm there. I really didn't like the color scheme they'd chosen. So. Oops. So I really had to leave that place in a hurry. And this is my favorite. I just particularly love this quote here. Not legal, but useful. That's kind of what I felt about the whole situation, really. So. Okay, so that's back-end stuff. So what else could I do? I could change the status on some things. So minibar. Amazingly, I haven't had anything out of it. It's all zeros. And I can DOS my room, so when the floor's covered in empty minibar bottles and stuff, you can flag it as already clean, and they won't come and bother you. So. Say again? Just no, okay. I even found that sometimes there's like a feature on the system that is there but has been switched off. So I think they're kind of implemented as standard, but each hotel chooses whether or not to switch these things on or not. So if you look at this menu, I've got movies, I've got PlayStation, the usual stuff, but there's no internet on there anyway. That's the whole of the movie, the whole of the menu system. And yet I found another channel which has internet on it. And it wasn't just a holding page, this was actually working. If I clicked on these links, they took me somewhere. And if I followed it through, I could actually get to a page with a search engine or whatever, and eventually you're out on the web. So it's almost like, yeah, they've implemented it. Maybe they use it internally, or it's only activated in certain rooms or whatever. So you can find stuff that's not necessarily activated. You can sometimes control physical devices. So here's the minibar in my room. here's the beer I wanted. Here's a red light showing I've accidentally locked the bloody thing. So that gave me the motivation to find the unlock code so I could get in and find the beer. You can view what other users are doing on the system, which can be interesting. And the reason you can do that is most of these systems, they broadcast everything. So it's not just that they're broadcasting the stuff they want to do, but they're broadcasting, even if you choose to do something specific, it will be broadcast, and then they will select that channel. So even though it's broadcast, it's only destined for you because they control the tuning of the TV. But if I control the tuning of the TV, I can go looking for that free channel as well. So here's a guy watching a movie. It's fairly harmless, but he's obviously some kind of anthropologist, I reckon. You know, he's interested in mountain-dwelling females. So that's pretty harmless, but what if he's going to the internet and he goes to his webmail and he starts reading his mail? So I'm at a conference with my competitors and we're staying in the same hotel, and I'm now reading what they're reading, or even helping them to write what they're writing. So. So the other thing I can do is assign the TV to another room. And once I've done that, I can view the folio, see the bill, or even potentially charge goods and services to another room. So as anyone here who's stayed in a hotel knows, you can go and look at your account status. So it looks up your name, brings up your bill, which strangely in my case seems to often be 0. Don't know why. And the reason it brings up my bill rather than someone else's is because the TV has an address, and the address tells it whose room it's in. So in this case, this address is A161. It's quite hard to read, but that's what it says. So if I change it, and it's now A162, hey presto, I'm in the room next door. And dear God, look at the bill he's run up. He must have watched every pay-per-view movie and drunk his minibar out like 5 times. Or was it 6? So anyway, I'm guessing this guy is probably going to have an issue when he tries to check out. So it's just a hunch. You know, he may have some issue with the bill. So I figure it's the least I can do is to kind of reach out and help the guy. So. Give him an early start, you know. He's going to need a bit of extra time, so, and send him on his way. So if I can do that for one room, why can't I do it for the whole hotel? So I get my digital camera and I write a little shell script, and I have the device that will send the commands. So I set it all up, go to bed, and when I get up in the morning, I have a handy little web page. And yes, I did spend one night in Paris Hilton, sorry. So now I have for each room a picture of the TV showing their folio and the room number. So here's my friend next door, and the odd couple next door to that. So if there's 2 people in the room, it will actually show you 2 different names. In this case, they happen to be the same, but Mrs. and whatever. Where they've been phoning. Depending on the hotel, some hotels you'll actually see the phone numbers they dialed. So by the time I'm done, I know how full the hotel is, who's in what room, with who, what they've been eating, drinking and viewing, where they've called and how long they've been there. So it's pretty scary stuff, really. Not something I should be able to find out from the comfort and safety of my own hotel room. So now we get to the real pay dirt. This is what you've all been waiting for. movies on demand. So it seems there's like two different kinds of systems. There's ones where it's truly on demand, and those are becoming more the norm. So you request a movie, the system broadcasts it to a specific channel and retunes your TV. Or the other ones are the ones where it's just going round all the time. And again, the controller just tunes to that particular channel. Sometimes they send a blocking signal because they've thought about this, people plugging their own tuners in and stuff. And actually, if you look at the back of a lot of these TVs, they have mechanical devices to try and stop you unscrewing the cable, so you can't do that. So here's an example. We've scanned the channels, and we think we've hit pay dirt because we got that really cheesy 70s music playing. But all we can see is this crap. And so I found a code that actually switches off the blocking signal. It does that by killing the computer, or it switches off the back-end system altogether. Excuse me, altogether. But sadly, in this case, it really was just a cheesy 70s movie, so it didn't get me anywhere. But as you can see, it's saying it's come back to life because there's no connection to the computer. So one of the other ways you could do it is to just retune all the channels. So we go through auto programming, and I apologize for the blurry picture here, but I've done a lot of research into this, and it's just not possible to take a clear, crisp picture with one hand. So. And there's that educational movie that you were looking for, which of course you tag so that you can find it later. Now, if all that seems like way too much work, they have this wonderful feature called the Barker channel. This is the channel that comes on when you first switch the TV on. So you can see what's coming, can't you? So I've set my channel to the magic number. Okay, so that was TV stuff. Stuff I've been looking at since I put this together is some of the newer IP-based hotel entertainment systems, which are actually even more interesting. I'll try and include some stuff in an updated talk, but they seem to be getting worse at security, not better. So there's a lot of back-end systems being integrated here, and they're just whacking it all on the same IP subnet, and it's all a bit scary, really. Car alarms, again, I'm looking at the RF systems, because I believe they're just simply changing the carrier. The codes are still going to be really simple, but they're going to use RF instead, or they are using RF instead of infrared. Hotel safes, I'll talk about that in a second, and TV be gone. So this is the car alarm stuff I started looking at. And actually I had a major breakthrough when, again, it was at the end of DEF CON, and I'm sitting in the States and it was all finished and we're having a drink in the bar. And my wife calls me up and says, "Oh, you never guess what happened. You know, I got stuck in a car park." And basically it was getting late. She was in a car park with about 4 kids, only one of them mine, by the way. And a lot of shopping, and she goes to her car and she presses the button and nothing happens. And it's quite a rough town, and it's, she's in an underground car park, it's getting dark, and she was getting worried. So she phones the garage up and says, "Look, I'm locked out of my car. What do I do?" "Oh, not to worry, madam, we'll be with you in 2 hours." No, you don't understand. I'm alone in a car park, it's getting dark, I need to get into my car now. "Okay, we'll get the engineer to call you." So the engineer calls, and he says, "Well, I'm not supposed to tell you this, but if you do this, the car will open." So he tells her the sequence. So she phones me and tells me this story. So obviously, I'm sitting thousands of miles away, and my wife just had this horrible experience. So the first thing I say to her is, "Are you okay?" No. First thing I say is, "You did write down the code, didn't you?" And of course she had. She's a good hacker's wife. And if you ask me nicely, I'll tell you too. So. The other thing I've noticed is a lot of hotel safes. Oh, actually, sorry, one last thing on that. I actually got a chance to test it. A friend of mine gave me a lift in a borrowed car, and he had to pick up his car. And as we were getting out of the car, he locks the car. And I noticed that he's using the same remote. So I said, oh, hang on a minute, let me try something. So by now, I'm carrying one of these around with me religiously, of course. So I try the sequence. And I mean, it was late and I was tired and I really wasn't thinking straight, but the place to test these things is not on a garage forecourt with like 50 cars on it. Okay, so it's a really bad idea. So we ran away fast. So yeah, hotel safes, a lot of them, actually pretty much every hotel safe, if you look closer, you'll find there's an emergency access facility of some kind. Usually in the handle, there'll be like an edge connector, or underneath a sticker, there'll be a panel or something that pops off, and there's a little plug that they can plug in. And quite often, they're infrared dongles, and they come along with a little PDA, and they do some magic, and the safe opens. So as you can imagine, I've been having a lot of trouble with my safe recently, so wherever I stay, that's strange. This one is great, TV Begons. Anyone played with one of these? Come across these? Yeah? One or two people. Basically, guy in the States found that there's a prototyping package you can buy, which is for doing infrared, and it's a single chip infrared transmission system, and with it comes a database of about 5,000 codes. What this guy did for all the different TVs that exist, he got the system and he deleted every code except the off codes, and then he programmed this thing. So basically it has every off code known to man in it. So you press the button once and it just says off, 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 and eventually whatever TV it is will go off. And if it's a wall of TVs in a shop, they'll all go off. And which is really cool. So I thought, well, if you could do that, maybe you could program a sequence of codes in there, and it could do something other than just switch it off. So if you watch this lady's face here, or the TV next to her, this is my idea. So, TV be prawn. Off, on, off, on. Yeah. So simple. That's it. Any questions? Nope, you can go home then.
All right. Yes, this is great fun. Infrared is used elsewhere as well. I'm thinking specifically of the Vesco data security products that some European banks are using. They have infrared receivers on them on the front. They are some kind of signature device. You get a couple of digits code from the bank webpage. You enter it to the device. You get a signature code back, enter it on the webpage, and you're authenticated. They also accept this form of authentication on the phone. Do you know anything about those?
I've never heard of those, but so is this a device you carry yourself, or it's only
yes, it
actually...
is. It's the bank issues it to you, and...
Do you have one with you?
Yes, I do.
Excellent. Come and see me after school. Yeah, we should look at it. It'll be interesting.
Yeah, all right.
Cool. Anything else? No? Okay, that's it then. Thank you.